So welcome to our last section, section 2.5, the last section of chapter 2. So in a previous example, using $23.74, we need to add 7/10, which is right here, and 4/100, which is right here. The key to such addition will be our number lines for the visual display and units for the explanation. Again, we rarely encounter arithmetic in the real world unless our numbers are associated with something, right? We call these things units. So here's just an example from the reading that you're responsible for. My herd consists of 3 alpacas, and then I add 2 more alpacas. How many alpacas do I have? Well, it's pretty obvious, but what it is obviously 3 alpacas plus 2 alpacas is 5 alpacas. In this problem, we have 2 items with the same unit, specifically alpacas. That's what they are. So we can add them. And here's just an example of how we're going to use our number lines. We have 3 alpacas. I add 2 more, and I get a total of 5 alpacas. Again, this is for the reading, but this is actually an extremely important one to go over. What is the sum of 3 cats and 2 dogs? Okay? Now, while the numbers are the same as our previous example, in other words, 3 alpacas plus 2 alpacas, the units are not the same. Cats do not equal dogs. We cannot add cats and dogs. All we can say is 3 cats plus 2 dogs equals 3 cats plus 2 dogs. Or create a new unit, pets. And then we can say 3 pets plus 2 pets is 5 pets. Addition of fractions follows this same basic rule. In fact, all addition follows this rule. And by caveat, all subtraction follows this rule. And the rule is you can only add numbers with the same units. This is a key concept. Okay, so this one you're responsible for, and it is, what is the sum of the following? So I'm going to do this one first. Notice this is the quantity, how many we have, and this is the unit. Okay? So we're not going to be able to add 6 10s and 6 1s and get 8 of something because we cannot add different units. But we can add 2 10s and 3 10s and get 5 10s. And we can add, just let the 6 1s carry on, right? And you would know this number as 56. This one is 2 tenths, which is this, plus 4 hundredths, which is this, plus 6 thousandths, which is this. This is writing it, and this is writing it in fractions. Now we can't add these because they are different units. You can't add tenths and hundredths in the same way you can't add tens and ones. What we can do is change 2 tenths and 4 hundredths into thousands. And so we'll do that over here. Here's 2 tenths. I'm going to change it into thousands. Now there is a pattern to this if you recognize it. So I'm going to multiply the top by 100 and the bottom by 100, which is essentially 1. And I'm going to get 200 thousandths. So 2 tenths is the same as 200 thousandths. I'm going to add to that 4 hundredths. Now 4 hundredths multiply by 10 over 10. I'm going to get 40 over 1,000. So I'm going to add to that 40 over 1,000. Because these are equivalent, because I took a number, multiplied it by 1. And finally I have 6,000s, which is going to give me 246,000. Now you might have been able to do that without going through this process by recognizing that 2/10 is the same as 200,000 by moving the decimal 2 places on the numerator and denominator, which is the equivalent of multiplying by 100. Okay, so let's look at this one. This is algebra, but it's the same thing. These are x's, and you have 3 of them. In the same way, these are tenths, and you have 2 of them. So I can add the 3 x's and the 5 x's and get 8 x's. But the 2 y's are just going to have to tag along because I can't add y's and x's in the same way I can't add 10s and 1s. Now here's 3/5 plus 5/10. I'm going to write this as fraction notation. There's 3/5 plus 5/10. Now I can change the 3/5, I hope you can see this, change the 3/5 into tenths by multiplying by 2 over 2, so I get 6/10. So now I have 3/5 is equivalent to 6/10, right? So now I have 6/10 plus 5/10. And I can add these together and get 11/10. Now the unit doesn't change, right? When you add, when I add up here 2/10 and 3/10, I get 5/10. I don't get 5 of something else. When you add 3 alpacas and 2 alpacas, you get 5 alpacas. You don't get 5 of something else. In the same way with fractions, you add how many you have of them, but you don't add the unit. The unit stays the same. And of course, you can change that if you want to 1 1/10. Now, does all addition follow the same basic rule as fractions? Namely, you can only add, and I should include or subtract, numbers with the same units. And the answer is absolutely yes. You can only add numbers if the units are the same. Those units are key. So example 2.24a, which you're responsible for turning in, we're going to add 5, 6, and 4/9. I'll write these in fraction notation. That would be 5, 6, and this would be 4/9. Now notice, I cannot multiply a whole number, 6, by a whole number and get 9. Nor can I reduce 4/9 and get 6. So there's 2 ways to approach this. One, you can always just multiply the denominators and get a multiple, which in this case would be 54, and use that and change both of these fractions into the unit 54. Or you can look for multiples. The least common multiple. And the multiples of 6 are 6, 12, 18, 24, right? 6 times 1, 2, 3, 4. And 9 is 9 times 1, 9 times 2, 9 times 3. And I am really done because there is my least common multiple. So I'm going to change the units of each of these fractions into 18ths. So I can go 5, 6 times 3 over 3, which is 1, is 15/18. So I can just swap this out for 15/18. And I'm going to change 4/9, multiply it by 2 over 2 into 8/18. So I can swap this out into 8/18. So I changed the units so that the units were the same, namely 18. So if the units are the same, I could just go ahead and add how many I have of each, which would be 23, and 23/18, which you can, it's an improper fraction, obviously it's more than 1. It didn't ask to, but I could turn it into a mixed number, which would be this. So fractions follow the same basic rule. You cannot add fractions with different units. You have to change the units in order to add the fraction. Now, most importantly, 5, 6, and 15/18 are the same number, and 4/9 and 8/18 are the same number. If you take any number and multiply it by 1, you will get the same number back in a different form if you use things like this. So you're responsible for this one, and it is actually really simple to write it as a fraction and a decimal. I'm going to do it the long way, but if you followed from what I was doing, as a decimal, this is going to be no ones. I have 5 in the tenths place. I have 4 in the hundredths place. And I have 9 in the thousandths place. So there's the decimal of this number. Remember, these are compiled the same way. So this is 5/10 plus 4 hundredths plus 9 thousandths. And that's sort of the expanded form of it, but that's what it means. Now you can also write this, if you could see it, as 549 over 1,000. And how did I do that? Well, because 5/10 is the same as 500 thousandths. Move the decimal 2 places, move the decimal 2 places. That is equivalent to multiplying by 100 over 100. And 4 hundredths is the same as 40 over 1,000. So I have 540 and 9 thousandths over 1,000. So welcome 2.26a. Hey, algebra. The funny thing is, algebra is nothing more than an extension of numeracy and basic math. So recall that 4x means 4 times x, right? They just too lazy to put the times sign between them. So all we're doing here is like, consider x like a dog. So I got 4 dogs plus 2 dogs, take away 3 dogs. That's all we're doing, because you just add. When you add how many you have of each, and then you just leave the unit alone. In other words, the dogs don't become cats. So I just have 3x equals 25. 6 minus 3, right? Now I'm going to divide by 3, both sides. And the reason I did that is because of what you've already learned. 3 divided by 3 is 1. So I have 1 times x, which is the same as x, because 1 times any number is itself. And I could turn this into a mixed number if I want. That would be 8. 25 divided by 3. And 1/3 left over, right? This is the same thing, it just involves fractions. I have 2/3 and 2/6. 2/3 of these, 2/6 of these. These are the same things, so I can add them. If this was 2/3 x plus 2/6 y, there's nothing I can do, because I can't add things that are not the same. Right? You can't add cats and dogs, but they are the same. So I'm just going to take 2/3. I'm going to change it into an equivalent fraction with 6 as my denominator. Multiply by 2 over 2, and I get 4/6. So I get 4/6 plus 2/6, and that's going to equal 6/6, which remarkably is 1. So that's just 1x, which is just x. So x equals 10. And just to show you how that would work, I'm going to replace x with 10 in the equation. And when I do that, it better equal this, otherwise I made a mistake, right? So this is 20/3, right? 20 over 3 plus 20 over 6. Let's change this to 6. 20 over 3 times 2 over 2 is 40 over 6. So I have 40 over 6 plus 20 over 6, which is just 60 of those 6, and 60 divided by 6 is 10. So it all checks out. That's the way to check your work. So we're just going to discuss 2.27, which is part of the reading, correct? So we measured 3 small items, and they had these different lengths. All right, what's the total length of the items? So recall that if you have two numbers, right, a 3 and a half, and you have place values for each one of them. So they're put together with addition, right? So I have 3 plus 1/2 plus 2 plus 3/8 plus 2 plus 1/16. And I can rearrange them because the order doesn't matter when you add. So I can rearrange them or just do the whole numbers and then do the fractions. And that's because addition is commutative, meaning you can add numbers in any order. So after adding the whole numbers, I have 1/2 plus 3/8 plus 1/16 I need to add together. Crucially here, to add fractions, we need to have the same units, right? We can't have cats and dogs. We could try to find equivalent of halves for each of the fractions. In other words, I could try to change 3/8 into halves, but how many would I have? It's difficult, right? See that? Here's 3/8, trying to change them into halves. I don't know how many that is. 4 halves, 4/8 is 1/2, but 3/8, I don't know how many halves that is. And then 1/16, I don't know how many halves that is. So from the arrows, you can see it's difficult to exactly determine how many halves 1/6 would equal or how many halves 3/8 would equal. In particular, we see that 1/16 and 3/8 would be less than 1/2. That's all we can say. So just as a caution, in order to add or subtract fractions, they must have the same unit or denominator. It's generally called a common multiple or common denominator. We can easily represent 1/2 and 3/8 as 16ths. So we're going to change 1/2 and 3/8 into 16ths. And we do that by taking 1/2. We need to multiply it by 8 to get 16. 8 over 8 is 1. So 1/2 and 8/16 are the same number. Likewise with 3/8. 3/8 and 6/16 are the same number. So we're changing them all into 16ths. So I have 1/16. I changed 3/8 into 6/16. It should be back a little bit, or I could actually add that in. 6/16, and I could change 1/2 into 8/16. So 1 plus 6 plus 8 is going to give me 15/16. Adding them on a number line. And so I'll do one problem like this. But that's a good review. Okay, so in this, which is the last one you're responsible for, and the last one of the chapter, we have 4 items, and here are their lengths, and we want to add them together. So we want to find their total length. Note that they are all inches, right? All inches. That designates an inch. So we can add them. Now, one was an inch and one was a mile, and you couldn't add them, right? You can only add dogs and dogs. You can't add cats and dogs, no matter what. Okay, so I'm going to write this down in sort of expanded form. I got 3 plus 4 plus 1/2 plus 5 plus 3/4 plus 3 plus 3/8. So I'm going to add all my whole numbers together. 7, 12, 15. So I have 15 inches, and now I need to add my fractions. Notice I have halves, fourths, and eighths. The easiest thing to do is to change these into eighths, because 8 is a multiple of 4. In other words, 4 times a whole number 2 is 8. So that'll be easy. And 2 times a whole number 4 would be 8. So they're going to be easy to change into eighths. So I'm going to change 1/2 into eighths, and I'm going to change 3/4 into the unit eighths. And I can do that by multiplying by 1. So this is going to be 4/4. So that's 4/8. And this is going to be 2/2. So that's 6/8. And I already have 3/8. So I'm going to have a total of 10 13/8. Now, being this is the 10th place, right? I mean, it's the remainder. It is more than 1. So we don't leave it like this. We regroup. So I'm going to do it this way. I got 8/8 is 1 and another 5/8. So I have 1 plus 5/8. So I have 16, regroup to 1, and I've got 5/8. Now, if this is unclear to you, you might want to watch this again. Well, these are what you're going to be taking pictures of. This is the work from the video, which you already have the answers to. So you're just going to put the answers in here and there, and here's where our homework starts. Add the following. Now, perhaps you're going to have a little problem with this one, so I'm going to give you a little bit on this. This is pretty easy, right? This is just to reinforce the idea you can only add things that have the same unit, right? This one I'll give you a hint on in a second. That's problem 1. These you should be able to handle because we did these in the video. I'm going to give you a hint on 6. This is kind of a review, right? So it's just good to know. I think you should be able to handle these. And these we did in, you're not going to be able to, these we did in the video, so you should have a good handle on those. And I'll do one of those. So I got 3 problems I'm going to do now for you. So here are our examples from the homework I said I would go over. So this is from homework problem 1. Notice that y squareds there is no other y squareds. It's not the same as y, because 3 is not the same as 3 squared, right? 3 is 3, 3 squared is 9. They're not the same. So I can't add anything to it, so I'm just left with 5y squared. That's all I can do. Plus, look, I have t squareds here and t squareds here, so I can add those together, and I get 13 of whatever it is, and whatever it is t squared. And the y's I can add together. I can add 8 and 3 and get plus 11 y's. Now, there's nothing more I can do to this. I've added the same units together, and I am left with that. Recall that, like, 10 to the negative 1 means 1/10. Recall that 10 to the negative 2 means 1 over 10 squared, which is the same as 1 over 100. So 5 to the negative 2 means 1 over 5 squared. This is by definition, or 1/25. So 8 to the negative 2, I've got 65 of those. And 8 to the negative 2 is 1 over 8 squared, which is 1 over 64. Now, how do you multiply fractions? Straight across. So this is going to be 65 times 1, which is 65, and 1 times 64 is 64. And I'm sure you can make that into a mixed number. Now I'm going to add these and express it as a fraction, right? So I have 2/10 plus 7/100. I can change tenths into hundreds. 2/10 times 10 over 10 equals 20 over 100. Now I have the same units. I have 20 over 100 plus 7 over 100. So I'm going to get 27 over 100. So this is 27 hundredths, right? We're adding, just like when we add dogs and dogs, you don't change the unit. Okay, well, good luck.